Next, we have Mark Nelson from Radiant Energy Fund. I've known Mark since 2016 when we worked together at Environmental Progress. Since then, he traveled the world. He's been seen on Bloomberg, NBC, a well-known international nuclear energy expert.
This is my very first time at this conference. I am very excited for tonight when, for me, it will be the second time I will have viewed Frankie Fenton's documentary. I was lucky enough to be in the audience in Toronto when it premiered. Sometimes you can forget where you've come from. You heard a little bit from Eric about my work with him back in 2016 when I made Excel charts and crunched numbers. And since then, it's been a whirlwind. The world has changed. We've gone from being, you might say, insurgents or loners, weirdos, some of us, all the way to where, more often than not, we'll find that we will try to convince somebody about nuclear, but they already know about it, and they're trying to convince us with the arguments that we put online a decade ago. So, congratulations to you all here. You are now officially the cool kids. But for me, again, traveling around the world, it seems very exciting. Sometimes it is, sometimes it's terrible. It was a precious thing for me to go to Toronto and slow down and see the beginning. I had never actually realized the importance of this conference, even in my own life. And I'll tell you about that. So Radiant Energy Fund is my effort to save nuclear plants from closing. Fortunately, there's not as much of that to go around these days. We have saved a lot of nuclear plants in partnership with all of you, many of the speakers we've heard today. And we're moving on to getting new nuclear plants built. So this was my coming out party to your world. I had been a graduate student. I left my graduate studies, more on that in a moment, and I was trying to figure out why it seemed so clear to me that we should do nuclear, but almost all of the experts seemed to be saying we shouldn't. And I'm talking experts who weren't afraid of nuclear. They weren't worried about the waste. I'm talking about experts that weren't really worried about the safety. They were saying that nuclear energy was too slow, too expensive, right? So I was in Cleveland, Ohio, trying to figure out how to access hourly electricity data. I made a chart. I posted it to a private Google group. And then Rod Adams, bless his heart, he took my graphic, and without my permission, that glorious bastard, he put it on the internet, on Twitter, a website I had never used before. And then he reported back and said, hey, sorry, I put your graph on Twitter. I think you should see what's happening. I think it's my best tweet ever. And then other people started posting it. And then Michael Schellenberger posted it, and it went boom. And again, I'm trying to figure out how to log onto Twitter, how to make a Twitter account. And I'm still kind of an unemployed bum on a couch in Cleveland trying to figure out what to do after a failed PhD. And suddenly I have this chart, which, have any of you seen this chart before? Okay, so some people have. What this was simply showing people how clean or dirty two different nations' electricity was. This is not difficult. This won't earn anybody a PhD. But at the time, nobody had bothered to just do the very simple math. That's where I come from. Until I saw Frankie's documentary a few months ago, and I realized that's not where I came from. I came from this. I hear from your response that some of you may know what YouTube video this is. I was a confused undergraduate coming to the end of my studies in aerospace engineering and Russian, a weird combo, but it makes more sense now. And I had no clue what I wanted to do. I wanted to do something big and meaningful, and somehow I sort of lost the desire to go into, say, space programs, because I felt like we had so many problems here that if other people were taking care of space, I could turn my attention here. But I didn't know what I could do as an engineer to make a real difference. One night, while I was trying to figure out what to apply to for grad school, I came across some post on some forum saying, hey guys, check out this video. And within about 5 minutes of starting this video, I decided right there, and I've never changed my mind, to stay in nuclear energy my whole life. Further confusing you all by jumping around in time, last night, I get to the hotel where I'm staying with some of the other speakers, and I talk to Gordon. Hey, Gordon, where are you? So I talked to Gordon here in the green shirt, and I was describing what I was going to talk about today, how I only recently realized just how important it was that I saw this video when I did, and it did come out of the thorium community, and Gordon said, yeah, was that the Calgary event? I said, I'm not sure, I think so, 2011. Gordon said, yeah, I got Kirk to come to Calgary. So I sat there last night and realized, wait, Gordon, part of this group, a key member of this movement, the thorium movement, got that video on the internet, and it changed the entire course of my life in 5 minutes. Well, that's when I realized that I had to tell you thank you, first of all, and then I had to tell you what's about to happen from that beginning. You are about to see what you have started in the world. You may have some idea, but you may not know the full scope of what this movement has done to change the world. So I finished watching the YouTube video, and then I went and applied for grad school, and I went to one of the oldest places in the world to learn humanity's newest energy source. A very weird vibe. As soon as I arrived, they said, oh yeah, thorium's a waste of your time, don't study that. So I immediately stopped thinking about thorium for many years. Don't worry, everybody. We're coming back to the good stuff. So this is the environment where I started learning about nuclear energy. This is Cambridge University. This is my college, Pembroke College, one of the oldest colleges, very close to the engineering department, so you could be reading on the internet all the way up till 3 minutes before your lecture starts and still make it there on time. And what will you read on the internet? Everything nuclear. It wasn't just a grad program. I was absolutely obsessed, as I believe probably many of the people in this room are. In fact, what I could say differentiates a lot of the people in this room from even some of the professionals in the industry is the absolute obsession with the idea that we're on the cusp of something revolutionary, that if we could just tell everybody, if we can just get the word out and we can just get moving on the technology in our own time, we can see a new world. Am I right? Is that not what the purpose of this? So I dropped out of my PhD, came back to America, made that chart, got recruited to a think tank in the Bay Area, and then quickly switched over to work with this gentleman, Michael Schellenberger at Environmental Progress. Michael had a radical idea. If nuclear plants were closing, what on earth did it mean to talk about building new ones? Let me clarify. If working, profitable, safe nuclear plants were being shut down because of political obstruction, environmental opposition, and market conditions that were designed to be the death of nuclear plants, how could we claim that we could learn how to build nuclear again, establish the companies, gain the competence, build the supply chains, construct the plants, do all the testing, run them profitably in a world where we were shutting down reactors that were already doing that today? We spent very hard years, often alone, trying to save nuclear plants. When I say often alone, I mean the outside world wasn't with us. You know who was with us? A lot of the people right here in this room, when almost nobody else on the entire planet was with us. There's our staff. This is going to have to live in our hearts. It's closed. But what started there, and what started with Eric and Michael and a few other people who aren't in this room, I want to show you what it's become. One of the first truly international pro-nuclear movements. I'm not trying to say that this room isn't international, but there's a heavy North American presence, shall we say. And in North America, reactors were closing often for different reasons than in Europe. What happened here is that we called a meeting in Amsterdam in 2018 of as many people as could get there from around Europe to figure out what on earth we were going to do about this massive wave of nuclear plant closures. That turned into having a pro-nuclear demonstration, a real man bites dog moment for the world, pro-nuclear demonstration in Munich, in what is now the heart of pro-nuclear Germany. 2018 to 2022, everybody. Obviously, events were on our side, but this mattered. There are people in this picture founded their entire movements after this point. Well, obviously Eric had been working before that, but I see folks that have founded the Replanet Network, now one of the largest pro-nuclear NGOs on the planet. I see people who are rising up in position in international nuclear bodies. I see people who have started entire national movements, like some Finns are in here, somebody who started the movement in Norway. We could go around the room. I've got a 30-minute talk about almost every single person in this photo, and there's 100 behind me in this photo. That's what got moving in Munich. And here's what it's turned into. On a moment's notice, we were able to put around the world a message. We need to have a candlelight vigil, 2021, December 31st, near midnight, your local time, preferably at your German consulate, commemorating the shutoff of those 3 reactors that just closed a few months before the start of the war in Ukraine. We were able to organize that so fast because people have been there, they know the mission, they lead others, they stand up, and then they change the world. Here's what it now looks like. Each one of these is a national movement now. And they're growing and growing and growing. And now that smart money, not smart money that it's early, but smart money is that they delayed long enough to wait for a global energy crisis. People are piling in to work with the activists, many of whom themselves are starting companies or have nuclear educations and are joining these groups. That's what's growing. And that brings me back to this group right here, the one that started the journey for so many of us. This is a picture from April. I would like to introduce you to what I'm holding in my hand. Does anybody here know what that metal device is? Okay, anybody who's not Canadian? What is this?
CANDU bundle.
Yes, it's a CANDU fuel bundle. So CANDU, you know, sometimes people talk about in the thorium movement, there are these reactors we worked on back in the 50s. That's not impressive. I want to hear about reactors we worked on back in the 40s. Why am I holding this fuel bundle, and who's that? Mehul Shah, a businessman, Indian-American businessman, now living in Chicago. And he has built a number of companies in chemicals, in food supplies, in housing. He's been a home builder. Wherever he's gone, he's just found a way to make a good business, provide good service, and make some money doing it. Something crazy happened to him, very unfortunate. He heard about thorium over a decade ago, and he decided to make a company to make an advanced thorium reactor, right? A molten salt thorium reactor. His reactor just wasn't getting off the ground fast enough. And this happened instead. If I had to ask you guys how soon, which calendar year, profitable nuclear energy was going to be produced from thorium, the element thorium, when was that going to happen? Well, let's look at the steps, right? First, you have to invent the reactor or dig up an old reactor, get it ready for the prime time. Have to get the design licensed, right? Then you need to get it built. Then you need to troubleshoot it. All of that is before you start making any, profit based on nuclear. Now, I'm saying this word profit. A lot of us come out of an NGO mindset or a philanthropic mindset. But let me tell you that if you make a power plant that's making profit, you are doing the right thing for the world. If you make a power plant that's not making profit, you might still be doing the right thing, but it might not be long for the world. That's been the battle in nuclear, yes? So what is the earliest year somebody is willing to guess that we can make profitable nuclear energy based on thorium? 35, 26, 25. What I'm going to show you is a team effort involving some of the world's leading nuclear engineers to get profitable nuclear power from thorium energy by 2025.
Thank you.
For those of you who do not know about heavy water reactors, this is a slide that the team over at CleanCore put together. You may have heard about modular reactors, but can you really say your reactor's modular if your core isn't modular? In fact, what we learned at Vogel is you're only as good as your worst module. You're only as fast as your slowest module. You might not be fast at all. You might be slower because of modular building. Well, the CANDU system is interesting. It is derived from some of the oldest reactor systems ever invented, all the way back to before nuclear electricity. And the idea is this. If you don't have access to heavy forging, really large metal manufacturing where you stamp huge pieces of metal over a number of years into giant shapes. That's how we make our reactor pressure vessels, right? If you don't have that, what kind of reactor would you design? This was a reactor designed along the idea that if you don't have enrichment, what do you use inside? What do you use as your moderator? So the CANDU reactor, the Canadian deuterium uranium reactor, runs on natural uranium. It uses heavy water to squeeze every last bit of economy out of those neutrons bouncing around, avoids the absorbent effect of regular water. What this means is that without enrichment, and by using a bunch of small pressure tubes rather than one large heavy forging, you can fairly rapidly make a bunch of reactors. And if you're careful, you can refuel them while the reactor is operating. And if everything goes to plan, and it took a long time for things to go to plan, you could run for over 1,000 days straight at full power. Here's another thing. Imagine if you could set up supply chains very rapidly where a large number of smaller, lower tech suppliers could produce these much easier to design, much easier to manufacture and test and qualify reactor tubes. That's the CANDU reactor. I'm just describing it as if we just discovered it. Yeah, that's right. You know how people said if we just discovered nuclear today, we'd describe it as a miracle technology, and how some of those of us who come out of the advanced nuclear design movement say, if we had just come to this reactor model now, we'd call it advanced and we'd want to be using it. Well, I'm here to say that the CANDU is truly an advanced reactor. It's just already here. It just has one little issue. You have to fuel this thing all the time. It is hungry. It's like a vegan reactor. It's just constantly eating giant piles of grass and then constantly putting out uranium, freshly used. In fact, there's about 7 times the fuel and the high-level spent waste coming out of CANDU reactors compared to our pressurized water reactors that we have today. There's also a few other things. As people who know almost nothing else about nuclear can tell you after watching the hit HBO show Chernobyl, there's such a thing as a positive void coefficient of reactivity. They don't know all 4 of the words, but together they know it's bad. This is the way many countries regulated the CANDU out of their borders. They said because this reactor, even though it basically physically cannot have meltdowns of the type that have afflicted some of the other designs in use around the world, because of this one weird little quirk that doesn't matter for protecting the public, you can't build it. So this is one of the countries you, at the moment, cannot build this reactor. Well, if you could make a fuel that radically reduced the loading and unloading, reduced operating costs at the plant slightly, saved everybody a bit of money, and also eliminated plutonium production for those countries that are really worried about looking sketchy when they're building their nuclear program, then you might just have a winning play. It turns out what it requires is thorium plus HALEU, that's high-assay low-enriched uranium, put into an essentially unmodified CANDU fuel bundle and placed into an unmodified CANDU reactor. Quite astonishing. Now, a few other things are happening at the moment that make this very intriguing. Here's one. Canada has worked to refurbish almost all of its reactors. In fact, we've just had an announcement that Pickering Nuclear Power Station, the only major power plant that was not undergoing refurbishment, they are re-examining that in light of the severe energy crisis and extreme pressure from some of the extraordinary activists we have here today, like Sean Wagner, everybody, who's one of the key players in the Canadians for Nuclear Energy, along with Dr. Chris Kiefer, who's not here with us. So if you're refurbishing a CANDU, that means you're making new internals. You know, that modular core that I said? So if you already have a factory set up to make some of the main parts of a CANDU, and you're already up and running, and you're already good at doing it. In fact, these refurbishment operations are getting faster and faster and faster. You know what that starts to sound like? That starts to sound like a revival of nuclear energy. Just one problem. Is the CANDU advanced? It's about to be. I'm Very happy to make this one of the first public unveilings of ANEEL fuel. So the name ANEEL is an acronym. It's Advanced Nuclear Energy for Enriched Life. That speaks to Mehul Shah's, the founder's, experience where one of the things that would bring down his companies is when he built factories and gave out jobs and had guarantees that he would supply products from one country to another, and then the power went off. And the power goes off, you can't make your deliveries, you can't keep your employees, you can't keep paying taxes to the local government. It all crashes. Development stops. He was forced to deal with the problem of lives derailed, millions of lives derailed from power supplies that were not constant enough and not cheap enough. So that's what put the bug in his head to go into energy. And so when he finally found that you didn't have to reinvent the entire wheel just to make a better, say, axle, he named his fuel after this original desire to make lives better using energy. I think that's a message that brings a lot of us here today. For those of you who are proper nerds, the key thing here is that by adding a little bit of uranium enriched above normal levels for pressurized water reactors to a lot of thorium, and then being very careful about how you distribute the fuel in the bundle and the bundles in the core, you can increase the burnup, that is the fuel usage, by 7 times. Meaning the loading and unloading operations that are one of the major burdens for the cost of operating these CANDU reactors, which are otherwise so simple, so reliable, so you might say safe, even though we probably overuse the word safety because existing reactors are very good already. Well, you just make about everything better. You are able to rearrange your staffing, you're able to refurbish your equipment a lot less, and if you're able to save and know that you're going to save over a long period of time, you have a potentially transformative proposal that could help save plants like Pickering. Instead of just a few of the reactors at Pickering, why not all? If your cost of operation drops by 5 or 10%, that's a game changer in the world of electricity, if it can come soon enough. So let's talk about the timeline. These fuel pellets are not theory. They have been manufactured at Texas A&M last year, and they are waiting to go into a test reactor today at Idaho National Laboratory. Yeah, so this is not waiting. This is advanced thorium energy at our doorstep. Now, we have a problem in this country of not enough test reactors, so if we could ask you all for something, it is to annoy the crap out of all your representatives for a lot more test reactor funding. That would help everybody, because we do have to wait in line for critical uses like the US Navy, right? Then, when those fuel pellets go in the reactor, there's a full contract that's been signed and sealed with Idaho National Laboratory to undertake the highest irradiation burnup testing ever on thorium. The Clean Core team know this because they have obtained all the data from the most recent trials that got to the previous highest burnup levels. So this is going to be fundamentally new data and new science with thorium. And I urge you all to stay in close contact as we put it in the reactor and start getting results. So Idaho National Lab will then be, scraping it up and looking at all the data and looking at the isotopes produced and examining all the critical measurements that are going to show to regulators that this fuel is at least as safe, if not safer, than the existing fuel for CANDU reactors. Then we work with Canadian utilities, and it's off to the races. We're hoping 2025 for the delivery of the first commercial fuel bundles for usage up in Canada. Who is now on board? I have to tell you something. When I was talking excitedly about this technology to some folks in DC who are themselves very into advanced nuclear and working on their own nuclear companies, they stared at me and they said, "Mark Nelson, a thorium bro?" And I said, well, first of all, that's not quite fair. And then I realized, no, wait. Let me show you who's about to be thorium bros, some of the leading lights of world nuclear science. So for example, we've got some of the highest level, most experienced people in Canadian nuclear industry have joined this team. So here's a question I got. Okay, well maybe this fuel is cool, but the regulator will never approve it. I don't know. Canadian regulator seems to think that they're going to approve entirely new reactors, several at a time. I think that if we work well with their regulator, we're going to be able to make very quick progress on an unmodified, except for the fuel, CANDU bundle. So CleanCore just decided to work with the guy who is the leader of the entire regulatory apparatus in Canada. There's a quick way to know how to navigate the system. How about this? We need people who understand, truly understand fuel development. So they brought on Dr. Shervan from MIT, who's considered one of, if not the top nuclear fuel expert in the world. That'll do it. And then we brought on other people like Dr. ANEEL Kakudkar. He was one of the first people to join, and he's one of the leading lights of the entire Indian nuclear program. He's, I'm trying to think of, he's basically Weinberg. Alive, kicking, doing excellent work over in India. India, here's an interesting thing. When I ask people where the cheapest reactors in the world are coming from, they say China. And I'm like, well, good reactors, you know, 4 or 5 billion a pop, that's not bad. They say, well, what about Korea? 4 or 5, 6 billion a pop, not bad. They say Russia, depending on who you are, between 3 and 6 billion, you know. And then they guess USA, and I have to laugh. And then they guess France, and I make a cringe. It's India. They're building CANDU-derived reactors, the so-called horizontal pressurized tube reactors. They're building them for a price that is cheaper than a decent coal plant. With entirely indigenous supply chain, they don't have the heavy, they don't need the heavy forgings, right? You can scale up the supply for these types of reactors because it's a modular core. And that's typically the longest lead time and most difficult component. So let me pitch you on a vision. If India is ready to step out into the light and work to export its outstanding reactor technology, and the world is wanting this and willing to work with India, and there's, say, a fuel that can assure that this fuel stops plutonium production. I don't have to sell those of you in this room on why that's important to a lot of people. Then you have a little play that with existing technology might just decarbonize Africa, might just decarbonize the world, with reactors that have never had an irreparable core meltdown. Every CANDU reactor, to my knowledge, that has had a little bit of a little bit of slumpage and a little blockage, gets a little warm, well, you just replace the tube and you keep moving. That sounds like advanced nuclear to me. If we're working in partnership, USA, Canada, India, we have in our hands something that could very well deliver the vision that you all have talked about at this very conference for over a decade. Just have to reach out and grab it. Questions?
5 to 7, maybe 10% on the cost of electricity from CANDU. We're doing this, but you make it sound like it's a revolution, and you also used Albert Weinberg, and you're completely missing the point of Thorium Energy and modular reactors. They are at least 10 times better than what you can do with thorium in a CANDU reactor. I'm not saying that we should do thorium in a CANDU reactor. I think it's a good idea, but just try to make things into perspective.
Physics is not a charity. I think a lot of us are often explaining that point to those friends of ours that like other energy technologies, right? The world is not a charity. You have to produce more than you take in order to continue. In the long run, depending on where you divide the system boundary. Doing thorium in a way that didn't pay its own way, that's not good enough. That's not good enough. You've got to do thorium in a way that is worth it. Not because it's thorium. We love the ideas that we talk about when we talk about thorium. The excitement we have when we see any kind of breakthrough. But in the end, that truly doesn't matter beyond excitement. You have to use thorium in a way that pays for the effort you put into the thorium fuel cycle. Thorium has been attempted many times, usually very briefly. Unless you want your thorium revolution to be something that happens very briefly, it's got to pay for itself And what I think I've just presented is a compelling case that we've got something that will pay for itself plus some. The revolution that we want with thorium, it already happened. It's all of you. You thought it was the reactor. It wasn't. It was you. It was what you all started. It was what Gord started for me in my life with that video. The revolution has occurred. You have won on the revolutionary part. Now comes the hard part. I would argue that one of the things that has slowed us down in nuclear is being obsessed with the technology instead of with people. What I tried to show you with those slides is that the revolution you thought was going to come out of blueprints, in some ways it did. I'm here, and I helped build this world movement because of the reactors whose blueprints were showed in Kirk's immortal video. That wasn't the real revolution. The real revolution was the hearts we convinced along the way, and it was the entire countries that are seeing rapid increases in public support for nuclear this very day. Enjoy it. It's your victory. Now we have to win the peace that may or may not involve different reactors that we've learned to love in concept. It may or may not involve the reactors that we used to love and forgot about. But I'll tell you that the same things that led to this social revolution are going to be the types of thinking and the group efforts that produce the successful, novel, and advanced technologies of the future. I do appreciate the criticism, but I want to say that you've missed the victory that's already occurred.
Another reason to do thorium is that thorium unlocks the rare earth metals market for the Western world. Right now, thorium is blocking the ability to refine rare earths into metals, which we all really want if we want these electric cars and stuff like that.
All right, so near term, tons of thorium needed in CANDU reactors. If that helps, unlock the rare earths, that's outstanding.
Would you be able to explain your slide, your Excel slide, please?
Germany is red, ugly, and bad, and France is green, orderly, and beautiful, right? So what this is how much carbon is put into the atmosphere per unit of electricity generated. Now, the graph looks almost the same if you just do it on absolute how much carbon was put into each hour, because by happenstance, France and Germany make almost the same amount of electricity. But yeah, so this is the pollution to deliver electricity supply in two different nations.
Over what time course?
1 year. That's 8,760 data points for each country. So 1 per hour.
One of the things when I show people this graphic, I like to ask them, what do you think of the weather was like that day? And a lot of people, they kind of think about it a little bit. I say, was it windy? Was it sunny? Exactly. It's windy, sunny, low demand, that kind of stuff. And those are the days when it's looking a little bit better in Germany. But as you can tell, that's not happening all the time.
And now the graph, if I put up like a 2021 or 2022 graph, it would look basically the same, except Germany would look insane. It would be just crazy gyrations up and down because they have now 140 gigawatts of installed wind and solar capacity. And I think the lowest hour we found this year was something like 1.2 gigawatts. So it goes between radically more than electricity than it can use and almost none. And that's what gives you the variation.
Out of time. Wow, thank you, Mark.